Now, in 2.8, 2.8 is linear inequalities. Okay? I'm not going anywhere. Relax. Okay. So this is in your assignment. There's a couple things in your assignment that one of them I'm going to put on the screen here in a second. It's a picture of something that I wrote on the board last week. Also, there's a video where a guy talks about how to shade using a test point. But I'm going to go through what I think is an easier way. If you remember, linear inequalities, that means you're graphing a line. It's either a solid line or a dotted or dashed line. And then you shade on one side of that line or the other. Do you guys remember doing that?
Yeah.
Okay. Graph a line and then you shade on one side or the other. So first thing, this, if you want to take a picture of this, it's actually in your assignment, so you can screenshot right from Canvas, but I want to explain what this is. First off, there's two parts of this, okay? One is whether or not the line is solid or dashed or dotted, okay? In your problem, if we have the or equals to sign underneath, okay, it's going to be a solid line. What that means is all the points on that line are included in the solution set. Okay? If it's less than or equal to less than or greater than. Sorry, I said that wrong. If it's less than or greater than without the or equals to, then the line is dashed or dotted. And in Notability, the thing that's nice for those of you who haven't figured this out yet is, the eraser used to only be able to erase the entire writing. And now you can do a partial eraser. So what I found is making a dashed line in Notability just became a lot easier because I can draw the solid line and just erase the parts that I want to erase. Okay. Now, to determine the shading, okay, there's a video that I included in the assignment. This guy goes through and explains how to pick a test point, 0, 0, plug it in, see if it's true. If it's true, you shade that side. If it's false, you shade the other side. However, I think putting it into slope-intercept form will be easier for you to graph, 1, and 2 is easier to do your shading. Okay? And so I'm going to go through a problem, taking an inequality and putting it into slope-intercept form, and then shading that way. Okay? And I recommend to you that you follow this procedure. Okay? So here's the problem that we're going to look at. 4x minus 3y greater than 12. Now, in order to graph, the first thing I want to do is get this in slope-intercept form, which means get the y by itself. So I want you to do that right now. Go ahead and rearrange this inequality so the y is by itself. Go. So again, eventually what I want is just the y on the left-hand side by itself. And I want everything else to the right. What happens when you multiply or divide an inequality by a negative?
Oh, the sign flips.
Yeah, the inequality symbol has to flip over. So let's go through this real quick, okay? My first move is I'm going to move the 4x to the other side. Okay? That leaves me minus 3y greater than... Now I can't combine 12 minus 4x. This has an x, this doesn't. But I do want to put the x term first. So I just put negative 4x plus 12. Okay? Now, in order to get the y by itself, what do I need to get rid of? Negative 3. Bless you. So I'm going to have to divide by negative 3. And I have to divide everything by negative 3. Okay? And since I divided by a negative, this is going to have to change, that inequality. Bless you. So I have y. Now I have to flip it over because I divided by a negative. Negative divided by a negative is a positive, so I can just leave this as 4/3 x. A positive divided by a negative is a negative, so it's like that. Y less than 4/3 x minus 4. Now I have my slope, I have my y-intercept, I have y by itself. Because this is less than, and it's in slope-intercept form, which side of the line am I going to shade? Above it or below it? Below. So when it's less than or equal to, when it's in slope-intercept form, you shade below. But notice here, if you would have decided from the beginning that you were going to shade above because this is greater, you find out down here that would have been wrong. because it only works when it's in slope-intercept form. This would have fooled you.
Well, you gotta change the sign.
I had to flip it over because I divided by a negative. Okay? So let's look at the next slide, which has the equation correctly written out, and let's talk about how to graph it. Okay? So my y-intercept is what? What is the y-intercept? The y-intercept is -4. So I plot -4. Now where do I go from there to get another point? Up 4. And right or left 3? Right. Okay, so that's where my points are going to be. Okay, is the line going to be solid or dashed?
Wait, where's the second one? Where'd you put all?
I went up 4 and to the right 3. Okay, so the line is going to be dashed because there's no or equal to under here. Okay, so this is what my line kind of looks like right now. I freehanded it and it doesn't look very good. For you guys in Notability, you can make that solid line and then use the partial eraser and just erase bits of the line so that it looks dashed or dotted. Okay?
Yeah.
All right. Now, since it's in slope-intercept form, this tells me to shade below the line. So that's going to be over on this side, below the line. Okay? So that's my answer. And your shading doesn't have to be super perfect, but it should indicate. So what that means is all the points in that shaded region would make a true statement for my initial inequality.
Where'd you get that graph?
From the internet. Okay? Let's say you didn't put it in slope-intercept form. Okay?
But it's gonna work in slope-intercept form always, right?
Yes. But let's go back to the original equation real quick. What was it? It was 4x minus 3y greater than 12. Yeah? Okay? Now, let's say instead of putting it in slope-intercept form, you just decided to use x and y intercepts, which you can. And we've talked about this before. If I plug 0 in for x, now this is the y-intercept. Okay? I plug 0 in for x, then essentially, let's see if I can get a little shape in here. Essentially what happens is the x term goes away. Right? So if I solve the equation -3x equals 12, what would y be? -4. Well, we already have a point there, 0, -4, right? We had graphed that already. Now, if I plugged 0 in for y, which is the x-intercept, essentially what happens here is the y term goes away. So 4x equals 12. So what does x equal? 3. Oops. So that equals 3. And so I have a point there, 3, 0. It's still a dashed line. Now, the problem is, in order to use it in the form that it's in, you do have to choose a test point, which he talks about in the video. So whenever possible, test 0, 0. Since the line does not go through 0, 0, we're talking about this point right here. When I plug that in to the inequality, if it's true, I shade that side of the point. If it's false, you shade the other side. So when I plug 0, 0 in here, all of this equals 0. Is 0 greater than 12?
No.
It is not. That's false, which is why we shade the other side of the line. And he talks about that in the video. Okay? My point is, how you decide to graph the line is up to you. My recommendation is put it in slope-intercept form. If you like this better, do this. I don't care. But by now, you need to know how to graph a line. Okay, and which method you choose is up to you. All right. I think getting it into slope-intercept form saves you time.
I think that's easier.
And I also think that you guys are better at graphing that than you are using x and y intercepts. But I'm leaving that up to you. You can make that decision for yourself. Okay? When the y is by itself and there's no x, you're going to get a horizontal line.
Yes.
When x is by itself and there's no y, it's going to be a vertical line. And you're going to see some of that in the problems that you're working on today.